All right, C period, we are going to look at Unit 2, Lesson 6, which is about using equations to solve problems as opposed to a T-chart. We can still use the T-chart, but sometimes using an equation is an efficient way to solve a problem. I do like this warm-up here. I want you to do this first problem in your book. This is called the number talk, and we're talking about quotients with decimal points without calculating anything. Put these numbers in order from least to greatest. So no calculator, just kind of do that in your brain. So pause here, take care of that. And then when you're done, this question I love. It says, place the decimal point in the approximate location in the quotient. So let's say you've done this on your calculator, but in your calculator's display, there's a missing decimal point. We know the decimal has to go in that number somewhere. Where does it go? So we should get good at estimating these. So this is 42.6 divided by 7. So I'm going to ask myself, what's 42 divided by 7? If I think of a reasonable estimate, 42 divided by 7 is 6, which means that 42.6 divided by 7 should be around that number, which tells me the decimal should go between the 6 and the 0, 6.08571. And then it says use this answer to find the quotient of one of the previous expressions. So use that answer. Can you figure out one of these? Where would the decimal go? We know the digits will be those digits. Can you figure out where the decimal will go? Good warm-up today. All right, here's what we're going to work on. Let's see, concert ticket sales. It says a performer expects to sell 5,000 tickets for an upcoming concert. So I'm going to sketch this out. 5,000 tickets and sales. They want to make a total of $311,000 in ticket sales, and they expect to sell 5,000 tickets. So the question is, assuming all tickets are the same price, what is the price for one ticket? Well, when I do that, I'm really finding the constant of proportionality, and we know how to do this, right? We're going to divide, and I believe when I do that, you can check this on your calculator. I think I get $62.20. Yeah, I checked that on my calculator. One ticket would cost $62.20. So here's what I'm going to do. Instead of continuing to fill out that T-chart, I'm going to write an equation. And again, I'll write it as X and Y instead of T and S. My equation would be Y equals 6220 or 62.2 times X. So let's, instead of filling out the T-chart, let's see if we can use the equation to solve these other questions. How much will they make if they sell 7,000 tickets? Well, in this equation, the X is the number of tickets, right? So to find that out, I could multiply Y will equal 6220 times 7,000, and I'll let you guys get that answer. How much will they make if they sell 10,000 tickets? Well, I'm doing that same repeated operation, right? 6220 times 10,000. 6220 times 50,000. So multiply those out for me. How about for 120,000, for a million, for X? I still think a good way to organize this is by using our T-chart. It's a good way to easily display the data that we need. Instead of a bunch of different sentences, we could put it all in the T-chart. 1 million. It's a lot of zeros. I hope I got them right. And then X. So the idea there is it's that repeated operation. And I can use the T-chart, but I can also write the equation and use the equation. Now the next question, question number 4, is a little bit different. Question 4 says, if they make $379,420, how many tickets have they sold? Well, in that case, the Y is the amount of money that they made, right? 379,420 equals 62.20 times X. And I want to find out what X is. Well, let's see. X is 6220 times, that amount is 6220 times X. And the way I would solve that is I would divide by that constant of proportionality, or divide by the 6220. And I would get my answer. How many tickets will they have to sell to make $5 million? So then our 5 million would be over here. Why don't you find that out for me? This next question is about recycling. I don't like this question. It's very confusing. We're going to skip it. And that's pretty much it in the lesson. I'll read through the lesson summary with you. It says, remember that there is a proportional relationship between two quantities if their relationship can be represented by the form y equals kx. That k, that's our constant of proportionality. Constant of proportionality. And I don't know why they use k, but everybody uses k. Sometimes writing the equation is an easy way to solve a problem. For example, we know that Denali, the highest mountain peak in North America, is 20,300 feet above sea level. How many miles is that? There are 5,280 feet in 1 mile. So they've given us an equation that the feet is equal to 5,280 times the miles, where F represents the distance measured in feet, M represents the distance measured in miles. Since we know Denali is 20,310 feet, that's the F, above sea level, we could write that equation like this, and then to solve, we would divide by that 5,280, and there's our answer. Okay, so it's using an equation as opposed to a T-chart. Although we like the T-chart, we can still use the T-chart if we want to. We're going to work through these practice problems. I think we're skipping one of them, but check online to make sure we know which ones we're doing. We might not be skipping any. I don't remember off the top of my head right now. But I want to work through this question number 1 with you. A car is traveling down the highway at a constant speed described by the equation d equals 65t, where d represents the distance in miles that the car travels in speed at this speed in t hours. So t is our time and d is our distance. First question, what does the 65 tell us in this situation? Let's see. This would be my d, and this would be my t. If t was 1, that would mean 65 times 1 would give me that d. That would be 65. 65 is the constant of proportionality. What does that tell me? That's an important piece of information. It means that the car goes 65 miles in 1 hour. Okay? Again, going this way, multiplying by 65. Going backwards, dividing by 65. So finish answering that question. We're doing question 2. Yeah, now I remember. I think we're skipping question 3 and then finishing the other practice problems for homework. All right, so this is lesson 6. We'll do lesson 7 tomorrow, and then we're going to see how it goes at the end of the week. I'm not sure how we're going to wrap things up with Thanksgiving coming up next week. But lesson 6 today, lesson 7 tomorrow, and check your answer key for the homework problems for lesson 5. And that's it. Have a great day, Alpha, and we'll talk to you soon. Bye-bye.